Lesson 2.5, probability distributions. Our objective for this lesson is to be able to make a probability distribution for a given set of events. First, let's define probability distribution. A probability distribution is a summary that displays the probability for every possible event of interest. So this is usually displayed in a table or a histogram, and we're going to list out every possible event and then the probability for each of those events. Next, how to make a probability distribution. So just as we did with theoretical probability, the first thing we're going to do is we're going to list out all possible outcomes. And then we're going to identify all the outcomes that represent the same event. And we're going to find the probability for each of those events. And then step 3 is to make a table or figure that displays all the probabilities. So for example, in a table, we'll list out in one column all the possible events, and in the next column, list out all of the probabilities for those events. And in a histogram or other visual display, we're going to again list out all of the probabilities and then, or all of the events, and then visually show all of the probabilities for each of those events. Now the sum of all of the probabilities in a probability distribution must equal 1. And we're going to talk about why that is in our example. For our example, we're asked to make a probability distribution for the sum of the dice when two fair dice are rolled together. So the events here are going to be the various sums that we could get when we roll two dice. So we can't get a 1 because we're rolling two dice and the lowest number on either die is a 1. So the lowest number we can get is a 2. We can get a 1 and a 1, and that's going to give us a 2. We could also get a 3 or a 4, 5, 6, 7, 8, 9, 10, 11, or a 12. The highest number we could get is a 12, a 6, and a 6. So those are the 11 events that we could get if we roll two dice. Now we want to figure out the probability for each of those events. There's only one way that we can get a 2 out of the 36 possible outcomes for rolling two dice. So the probability of rolling a 2 is 1 out of 36, which is approximately equal to 0.028. For a 3, there's two ways to get a 3, two outcomes that give us a sum of 3. We can get a 1 and a 2, or a 2 and a 1. Those are two different outcomes, and they give us the same event of a 3. So our probability is 2 out of 36, which is approximately equal to 0.056. For a 4, we could get a 3 and a 1, or a 1 and a 3, or a 2 and a 2. So that's 3 outcomes that give us that event. So 3 out of 36, which is approximately equal to 0.083. For a 5, there's 4 outcomes that give us a 5. So that probability is going to be 4 divided by 36, which is about 0.111. For a 6, there's 5 different outcomes that give us a 6. So 5 divided by 36 is approximately 0.139. For a 7, we've talked about this in previous videos, there are 6 different ways that we could get a 7. So the probability is 6 divided by 36, which is approximately equal to 0.167. Now, for an 8, we start going back down. There's 5 different ways that we can get an 8. So 5 divided by 36 is going to give us 0.139 again. And for a 9, there's 4 ways that we could get a 9. 4 out of 36, which is 0.111. For a 10, there's 3 ways. which is, again, about 0.083. There's two ways to get an 11. So 2 divided by 36 is about 0.056. And there's one way to get a 12. So 1 divided by 36 is about 0.028. The total probability for any probability distribution should always be 1. And if you add up all of these probabilities, you'll find that they do add up to 1. Now, if you add the decimal probabilities, they might not be exactly 1. It might be 1.001 or something like that. And that's because we've rounded all of these decimal places off. But the reason that the probability should always add up to 1 is because in a probability distribution, we've listed the probabilities for every possible event. And so the total of every possible event is going to be a probability of 1. In other words, it's certain that one of these events is going to happen. Now let's make a histogram to visually show this probability distribution. So along the bottom, we're going to have events. And the events were 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then along this axis, we're going to have probability. And since we go from 0.028 up to a maximum of 1.67, I'm going to go in increments of 0.02. So we'll start with 0.02, 0.04, 0.06, 0.08, 0.1, 0.12, 0.14, 0.16, 0.18. All right, and now to make a histogram, the height, we're going to make little boxes for each of these, and the height of the box is going to tell us the probability of each of the events. So the probability of rolling a 2 was 0.028. So let's go up here to about right here, and then we can fill in this box with red. And that shows, the height of that box shows that the probability of rolling a 2 is about 0.028. And then for a 3, the probability is 0.056. So let's go up to about here for a 0.056. And then we can fill that in as well. And I'll fill that in a moment. 4, the probability is 0.083. So that's going to get us up to about here. And then for a 5, it's 0.111. This is maybe a little bit high. 0.111 gets us up to here. 6, the probability is 0.139. So that's going to be up to about here. And for a 7, we're going to be up to 0.167. So that's all the way up here. And then for 8, we're going to be stepping back down. So we'll go 8, and then 9, and then the 10 should be the same as the 4, and then the 11, and then the 12. And so I'll go ahead and fill these in, and we'll be able to see the finished histogram showing this probability distribution. All right, so now we have a completed histogram as well as a table showing the probability distribution for rolling 2 dice. And notice that this histogram is symmetrical, with the most likely event being rolling a 7, and going down on either side to the least likely events of rolling a 2 or a 12. And I want you to see if you notice a similar symmetry in the exercises in your homework.